super nice nowadays.
Yes, there.
When does the soccer season start? It's next week.
They stay in conference, so it starts March.
Did it always start March?
It used to be just April, and state was in May, and now it's starting in April, and state's conference.
That means more games though,
We
right?
play twice as many games.
Is the team good this year?
It's a great question.
That's a no.
So we had 15 seniors last year, and that's pretty much everyone who played. So we'll see how good.
Yeah, but they weren't any good, were they?
They should have done better in state.
I know before I quit, the senior year was really good. My freshman year and sophomore year, they were really good. And then they all left, and last year I heard it was rough, but it wasn't,
It
horrible.
wasn't bad. We were third in conference, and then we lost in the quarters.
This year, it's like, the height difference went from like everybody being
Yeah.
6 feet tall to like 5'6", 5'7".
Yes.
Wait, average is 5'6".
We average, yeah. I mean, because we lost like 15 seniors, and then we only brought up like 2 juniors and sophomores. So the average age is like a full 2 years.
Jack Zuth and John Bishop.
Yeah, they're really, really good.
I used to play with them, and then they split up the age groups, and I switched to a different team. Jack's actually my neighbor.
Oh, okay. Do you want us to turn this in right here? 33?
Yes.
I already turned it in yesterday. Do I have to return it in?
Well, I didn't see you yesterday, so it's not
Or,
possible.
I meant Monday.
I don't think you turned it in on Monday either.
I gave it to you, and then you handed it back and said you could until.
Turn it in this class, is what I said. Because I don't even have it in gradebook yet, so I didn't record it for sure.
So,
Ben, you ready for that parade tonight?
oh yeah. That should be the highlight of the year. What? Yes, it should be the highlight of the year.
No, it's not.
Yeah.
I can't remember which one it was, but one of our parades, for the longest time, it used to be a half school day, so that people could go and like work on the floats and participate in the parade.
I thought we'll later have the parade.
It might be that one, I don't know. It's been like almost 10 years since it was a half school day for that, so.
It's probably homecoming. What does the soccer floor look like?
We'll figure that out today.
You guys haven't done anything yet?
Oh, we got a lot of
my
school
God.
business today.
That's crazy.
We didn't do anything on practice in Monday, so I don't know what we would do. But yeah, we'll see.
They should have a band flow. That would be a good one.
That way you guys don't have to walk.
Well, like just a thing to go around that says, give money to the band, high school band, we need it.
Mr. Townsend, I forgot my binder today, so I'll just get that to you late next time, I guess.
Okay.
Just letting you know.
That means you have to take half credit on your quiz.
Oh. Well, that sucks.
Just kidding. You'll be fine.
The swing flow is always pretty good.
That is true.
It's the only one I can really work with.
You attended your hardest today,
And the football floor, because because they have all the money, so they get to go all out.
Did you tell him he was tender-hearted?
Yeah.
It's always cool though getting to
Is
see
there
them.
context?
We're calling
to
me
the-
we're calling me a different synonym of
They're
kind.
really nice cars.
Oh, okay.
Someone started that.
Okay.
Yesterday, the synonym had kind in it. It was kind-hearted, and I thought that was lazy, but they were just going down the list. So.
It's a really nice car.
It was like one like years ago. She had a really cool. one of the synonyms it lists is handsome, so when you get to that day, it's gonna be.
Okay, you know what I mean when I say really like nice school. I don't know. You know, he knows what I mean. He knows what I mean.
The nice part is, that's
Yeah, he knows what I mean. I heard that the only reason why the
Calvin,
Claire.
I was thinking once we were running out
I don't
of
see
synonyms, it would be fun if
Yeah,
like
not the only
we
reason.
went
but-
into the synonyms of all the
Brendan
synonyms
believes
until
that
we got to
her
the
name
word
was the very-
unkind or something like
It's pretty
that.
popular, so everybody saw her and just clicked on her. Oh, I don't know.
I wonder what word would take us there.
Well, that's how this.
I actually used to do that with my dog. Like I would tell him, you know, he was the best, and then I'd say something slightly worse, and then slightly worse, and just see how many things I could do, and then be like, you're okay.
If we went through.
I voted for Catholic Vote Jammer, who was one of the people
yeah,
as a part of
that's
it.
true.
And I just gave my phone to my friend and said, here, you can vote for your friends.
Also, Agatha claims system.
Yeah,
So it's probably the same thing.
I mean, they're popular, you know, that's something. It's almost guaranteed.
Okay, I do need your review from last class to give you the points for that. So if you didn't turn that in, please go ahead and start finding that in your binder.
October 23rd, 2024. Will you please join me for a minute of silence?
I don't know about that. I doubt that's very well.
Oh, what's going on?
There's no reason why you would skip.
The only reason I would look at it.
Yeah, I know my parents.
Oh, yeah. I'm not ready for that 10 quiz,
Bro. Next semester, you're actually gonna be a lot.
Well, it's just because the last two lectures he's given at one last week.
I had to wake you up like 3 times.
Yeah, I really need to do that.
And Mr. V?
No, Mr. Barba.
Oh yeah.
I fell asleep during the lecture Monday and Friday. Or, I can't remember, but
Will you please stand if you're able for the pledge?
I wasn't falling asleep. I didn't, I couldn't get it.
United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I didn't really work.
I really fall asleep, but like, chemistry is not the most exciting study.
Good morning.
Morning, this is Dr. Miller. Couple of quick announcements. Students, don't forget, we have no school on Friday, and you must have an ID to enter the homecoming dance Friday evening, so make sure that you're taking care of that. And all fines must be paid before you can purchase a homecoming ticket. So make sure you take care of all of that, because you won't be here Friday to take care of that before the dance. Thank you. Have a great day. Go Purple Dogs.
Sorry, I do want you guys to focus on your quiz. But have y'all ever wondered or thought, like our mascot? What is our mascot?
Bulldog?
The bulldog. It's because Springdale is also bulldog.
Well, I know, but we spell dogs D-A-W-G. And it's a school. And we're encouraging you to not spell the word correctly. Okay, anyway.
I thought it was D-O-G-S, like on the scoreboard and stuff.
Well, but we also spell it
Yeah.
the other way too.
I thought something that was like every crappy school is this as their mascot and showed a picture of like our logo.
Yeah.
Yeah.
Yeah. Yeah. The
like
bulldog is one of
Jack.
the most common mascots.
I mean, you could have been the Winslow Squirrels, so.
I know there's some school in Florida that's banana slugs.
Okay, our quiz is no calculator, so if you have a calculator out, I need you to put that up. Also, before you get going on here, if I didn't get number 33, your review from last class, I need that before you get started, please. I do have some handouts for you guys to pick up after the quiz. So we're gonna just spend a quick 5-10 minutes tops on the next topic. So don't rush through your quiz.
I got you. There's no way.
So don't rush through your quiz, but after you turn in your quiz, I do have the handout that we will start looking at on the front desk now. I didn't put it on the front desk before you got here just because I felt like it would be in the way anyway and you'd just be trying to put it up, so. Bless you.
Mr. Townsend.
I have you signed up for Tuesday to do your makeup quiz.
Perfect. That's actually the perfect time, so. I'm in Visitors. Actually, that's not allowed by school rules, I was gonna say. This I could run across, but I don't think that's allowed. I thought people to get in trouble.
For what?
We'll take up the quiz. I was just gonna say I could hop from one line to advisories during the week, but that's probably not the wisest decision.
I've got you signed up for Tuesday. Won't be an issue. Thank you.
You're welcome.
Mr. Townsend. This one, do I need to like look for that or is that fine? Like try to use that?
You need to go further than that.
Okay. definitely got like 3 years. That's one radio.
It's pretty accurate.
It's probably like 4 times this.
Oh, so Ben, how was that quiz?
Too nonchalant.
The only one that tripped me up was the one that was in respect to Tuesday.
Oh yeah, don't you just multiply everything?
That's what I do. I plugged 2 together.
That's what you do. That's what I do.
They're all done. We're just talking about test answers while he's taking the test.
Well, that's what I was worried about. Okay, so there are 3 handouts on the front table, so if you forgot to go get those, I need you to get them. You probably want to staple them together, and you might want to 3-hole punch them. But again, we're only going to look at these for just a couple minutes. So, nothing really to worry about, but I knew we'd have a lot of extra time here. So anytime we can start thinking about the next topic, divide it up a little bit more is obviously a plus. Okay, so since we have started College Boards Unit 9, we have looked at 3 lessons on parametric equations. Then you guys just took a quiz over the next 3 lessons, which was on vector functions, and of course doing calculus with those, derivatives, integrals, blah blah blah, all the stuff that gets tied into that. And then the next 3 are on polar. So I know polar is new to most of you guys. So I think this first handout could be a little bit more difficult while we grasp the polar concepts. So let's talk about what polar means. We're going to look at how we can go back and forth between polar and rectangular form. Practice that on a couple. Show you how to do it in your calculator as well. And then that'll be good for today. Okay, so polar is just a different way to graph and graph points. So the rectangular coordinate system is the one you're used to. This is when you have an XY that tells you how far to go left or right, and then how far to go up or down, and then you plot your point. In polar, it's not XY, it's R theta. So R is the distance you're going, and it can even be negative, and theta is the direction you're going. So like if R was 2 and theta was whatever, pi over 4, you would go in the pi over 4 direction a distance of 2, and then you plot your point. Yeah.
So R could be negative?
Yes, it can. So,
Okay, how would that work when the angle could just be backwards?
right, so if r was negative 2, you would go negative 2 the direction of pi over 4. So it would actually be that in the other direction.
Why wouldn't it just be like R and then like whatever the other angle is?
What do you mean?
Like why wouldn't theta just be the other direction and not have the R as a negative?
Oh, it could. Those would be equal.
Okay.
So yeah, so we have a distance r and a direction theta, r comma theta. So one of the best things that you can do early with polar is learn how to change it to rectangular, since that's what you're more comfortable with. Remember, rectangular is the x comma y that you've always seen. So to determine x, x is r times cosine theta, and y is r times sine theta. Now, why should that kind of make sense that the cosine one goes to x and the sine one goes to y? Right, just like the unit circle. The x values are determined by cosine values, the y values are determined by sine values. They're simply multiplying it by that distance. So it keeps the same ratios that you're used to, but keeps the same ratios, but then it has this scalar where r is the distance. So then sometimes you want to go the other direction, and you'll be asked to go the other direction. So if you were given a point in xy and you wanted it in polar, to find r, so again, pretend like this is r and this is some value theta. To find this length, which we normally call x, and this length, which we normally call y. All right, you can see you've got a right triangle, so x squared plus y squared equals r squared. So here's, if you know how big r is, you can leverage that a little bit to figure out x and y. Now, it's not enough to figure out both, but there is that relationship there. Also, this is one way, but really any SOHCAHTOA way, if you need to know what the angle is. If you have opposite and adjacent, you could do inverse tangent of opposite over adjacent, y over x. So, regular old SOHCAHTOA stuff, but then do inverse to find the angles. I feel like there was one more thing I wanted to say about this first part, if I can remember. Actually, I guess not, but you might do like something like this. When you're going this direction, you might call that theta. When you go the other direction, what's the difference with that? If this is measuring theta, what happens when you go the other way?
Negative theta.
Right. So I had that down. I don't think it's going to help too much. Okay, but the first thing we need to do, again, so that we can have something to work off of, is just switching back and forth between these forms. So, convert all of these polar to rectangular. So what is r cosine theta equal to? X, and you're done. What is r cosine theta equal to? What is r squared equal to? Done. If you know that x is r cosine theta and y is r sine theta, and you know r squared is x squared plus y squared, you're really just making these substitutions. Everywhere there's an r cosine, switch it to an x. Everywhere there's an r squared, switch it to an x squared plus y squared. Or even if it was just an r, you could switch it to square root of x squared plus y squared. Okay. Any ideas how to start number 3?
You can multiply the denominator over to the other side.
Okay. Sounds good to me. Okay, somebody else, what would maybe be the next step? Okay, distribute your R. Okay, somebody else tell me one other thing you see now.
R sine theta could be y.
Okay, R sine theta is equivalent to the Y value, and the only other change we need to make is, right, switch R cosine to X. So in the end, this is the same as 4 is equal to 2x minus y. Okay, so I do want to do 2 more things with you on this handout, but I also want to show you some of the calculator stuff, because we do need to be able to play with this in our calculators a bit. So either get out your calculator, please, or come and borrow one. And basically what I would like to do here is, let's just use the first question, number 1. Let's just use this as an example and do this in our calculator. So, you guys know what x equals -4 looks like, right? It's a vertical line where x is always -4. Well, this graph should look the same. So graph this in your calculator. Graph R cosine theta equals -4. Okay, you're having issues, right? You should be. So first off, I mean, I guess you can force an R in here if you do alpha times, you can get an R. That's not really the R that we want though. This says y equals, and your calculator always says y equals when you hit the y equals button. Unless, I feel like this came up. Did this come up? Yeah, so if you hit the mode button, and you go down to the 5th option, you can change it to parametric if you ever want to graph a parametric equation. But we are looking at polar. So hit enter on polar so that it highlights that. And now what happens when you hit y equals? Right. It switches it in terms of r equals. And notice you're trying to graph in polar, so it shouldn't be y equals, it should have some r stuff in it. So to graph this question 1, we have to solve it for r equals. So divide both sides by cosine theta. Since there's a trig function, your calculator has to be in radian mode. And then what is this going to look like when I hit graph? You guys don't know what this is going to look like? We converted it to rectangular. We said we know what this looks like. It's not just a vertical line. It's the same as x equals -4, right? Which is the point of why when you convert this that these are equivalent. So when you hit graph, basically what it's doing is it's going around the unit circle, 0 to 2 pi, and it's taking those cosine values, or actually it's taking -4 divided by those cosine values, plotting those, and it comes up with a graph that is equivalent to x equals -4. Okay, if I wanted to do this for I guess we really couldn't do it for question 2 because there's multiple r's. We have to be able to solve it for r equals. But let's go ahead and graph question 3. by that I mean graph what we started with. Mhm.
I typed it right. Comes up looking at this little circle.
Mine didn't look like a circle.
Oh, I just typed it.
Are you in radian mode or degree mode or?
You gotta use that actually.
Did you use parentheses or on the denominator? I'm really excited about it.
Yeah, I was excited about that.
Did you type it in as one
I
big?
typed it in wrong, that's what it was.
Yeah, you either need parentheses around the numerator and denominator, or just have it type it in as a big fraction by doing alpha y equals 1. Okay, this looks pretty familiar. Doesn't this just look like a linear line? Okay, what does it look like the slope would be? Yeah, it is 2. You're right. But look at our answer on question 3. If we solve this for y equals, which we didn't have to do, which is fine, y is equal to positive 2x minus 4. So isn't the slope supposed to be 2 and the y-intercept supposed to be negative 4? So just a different way to represent it. Now again, I think you will need to be proficient with your calculator for polar stuff, so it's good for you to see the mode button. You can switch back and forth here. If you guys are taking physics or whatever, you might want to switch it back to function mode. But you do need to be aware of that, and of course it needs to be in radian. Okay. Oh, well, I don't want you to play with this right now, but since your calculators are out, polar coordinates are actually pretty cool to play around with. We used to teach polar for a couple weeks in pre-calculus, and we stopped doing that because you don't need to know polar for AB, and not everybody gets to BC, and then even if you learned it in pre-calculus, you don't necessarily remember it very well by the time you get to AB. So we took it out of the curriculum a few years ago. But there are some cool things. So like if you graphed just cosine theta, what it's going to do is theta is the variable, so it's going to go from 0 to 2 pi, and it's just going to keep plotting whatever the cosine value is what the radius value is at that angle.
That's where the circle comes from.
Yeah, and then if you want it to be bigger, you can just put a number out front, so each of those values are now going to get multiplied by 5. So you see how well, first off, does that look like a circle to you?
This is an oval.
It is a circle.
Oh.
Why does it look like an oval then?
Oh, it's because the X is a little bit more elongated because our screen's wider than this one.
Yeah, your calculator screen has more pixels horizontally than vertically, so it actually stretches your image a little bit. If you hit zoom 5 to go to square, it tries to compensate for that, and it tries to make it balance out. So if you do it square, you can actually see it looks more like a circle. Okay, but notice it's a circle that is based around what axis? It's right on top of the x-axis, right? So what do you think is going to happen if I change this cosine to a sine? Same thing, but it's highlighted over the y-axis. What do you think is going to happen if I make this a 5 in front of theta? Yeah, so it's making that every time you change the angle, it's actually increasing times 5 because of that 5, so it's moving along quicker. So when it does that, you end up with a flower with 5 petals. Well, how many petals do you think there's going to be if you do 7 petals?
7 petals.
Okay, how many petals do you think they're going to be if I put 4? 4? You're all wrong. So, okay, tell me a number to put here. That's less than 10.
10.
Okay, 10. How many petals do you think this is going to be?
4. No, 8.
5. 2. No. 1.
20.
Oh, that was
Okay, pick a different number.
100.
Less than 10.
Oh.
7.5.
Okay, we will do 100 one time. Get it out of your system.
What? Oh.
So what happened is the other ones were landed on top of the first ones, so it's not as.
That's not happening.
9.
Okay.
3 edition.
How many petals is 9 going to create?
18.
What if we do a decimal place?
Oh my.
9.
Square by.
Y'all have not figured out the pattern
I
yet.
have.
It's on the
If it's
top
odd,
as
it
well.
shows the right number, but if it's even, it shows double.
Very good. If it's an odd number next to theta, like 3, that's how many petals you get. If it's an even number, you actually get double that.
Why?
That's a good question. I don't know. I mean, you could look at some examples and look at the numbers that, like if you made a list, like basically the table, and you compared those, you could pick up on the pattern that was there. Square theta?
What happens if you put in a fraction? Like a decimal.
Well, you know, you guys have your calculators out too.
Oh.
That's really weird. Okay, what would happen if, now this one you should know. What happens if I put a plus 2 on the end?
It'll up to.
What?
So kind of. Yeah, so sometimes it kind of like loops back in.
So is the smaller loop the bigger the smaller the number is?
Bigger the smaller the number
Like
is.
the little middle loop?
Sure.
What happens when you subtract?
Great.
It ends up where it doesn't ever connect. It's the same.
Well, it might have accidentally been.
-2?
You can make so many different shapes with this stuff. Just playing around a little bit.
Okay, if I remember right, because again, it's been almost 10 years since we've done this in pre-cal, so I haven't played with this as much. I did a little bit this summer. Do you see how this is it just has like a little dimple here? I believe, and we can test it out, but I believe if these two numbers are the same, that's what happens. So if I do 5 and -5 or +5, I don't think the minus or the plus matters, but yeah. And actually, there's a name for this. If I make this a negative, what does that look like?
A heart.
Right, and what's the medical name for a heart? Cardioid. That's, yeah, and that's the name of this type of function.
What happens if you also put something, multiply the theta? Will it make like 4 of those, 5 of those, or whatever?
Sure, if you wanted 4 petals.
I want to see that.
Yeah.
Okay, well actually, I don't know. We did 2.
What?
Oh. But that's 100.
You have.
99, is that what it's
Square it too, square it too.
Oh, wait, these thetas look like zeros. That's confusing. Yeah, and then you can obviously make this.
What happens if you do sine squared?
Oh.
Yeah, so you can do some pretty cool stuff. So when we did this in pre-cal, there were certain things we expected them to know, like how many petals there would be, you know, based on the number next to theta and all that kind of stuff. But I don't think you'll need to know most of that. But I do want you to know that there are some pretty cool graphs you can come up with. It's kind of cool to play with. It's cool to adjust some stuff and see how it changes. So hold off on that for just a minute if you do want to mess around with that, because I want to look at this and the next question, and then that will be it for today. Okay, so it doesn't take too much practice to just take something like this and switch it to polar form, or take something like this and switch it to rectangular form. Once you memorize these couple substitution tools, if you will. But of course in calculus we are going to be taking derivatives and integrals and area under a curve and lots of normal calculus stuff. So if you want to find dy dx, this is like doing y prime of theta, or in terms of theta, over x prime in terms of theta. and here are those values. Now, I don't really love the way they do this. F of theta is just actually the value, which is really just r. So I tend to think of x is r cosine theta and y is r sine theta. I'm not a big fan of saying f theta cosine theta. Okay, so to take the derivative of r or y, you're going to be taking the derivative of r sine theta, and to do the derivative of x in terms of theta, you're going to be doing the derivative of r cosine theta. Okay, what rule would I have to use to do this derivative? You have to do the product rule for the numerator. Luckily, we get to do them separately. It's not the derivative of y divided by x. It's the derivative of y divided by the derivative of x. So luckily, we don't have to do quotient rule. But you could do the derivative of r with sine left alone plus r left alone times the derivative of sine, and then basically the same thing for the denominator. You could do the derivative of r with cosine left alone plus the derivative of the derivative of cosine with r left alone. So basically the product rule along the top two. So I don't know that this is so much a formula that I would encourage you to memorize, but you do need to know this and realize that if that's what you have, you would have to piece it together with product rule. So to do that for just one question, so last one we'll look at today, question 4. Notice it does say the following is an example of a common problem found on the AP exam. So I guess this is something that they like to ask a lot. What is the slope of the line tangent to the polar curve? So the radius length comes from 1 times 2 times whatever the sine of theta is. Again, theta is the thing that changes over time, just like you're used to x being the thing that moves along, but with polar radius, or theta is the thing that moves along when theta is 0. So what does slope of the tangent line imply that we need? Okay, we need the derivative, which is going to be found by doing y prime over x prime in terms of theta. Same thing as y sine theta derivative over x sine theta derivative, or sorry, x cosine theta derivative. Actually, scratch that. I am going to do that, but I should first figure out what r, or x and y equal, I'm sorry, because I need to plug those in. So x is r cosine theta, and in this question r is 1 plus 2 sine theta. So x, if I distribute, looks like that. The formula for y is r sine theta, and again in this question r is 1 plus 2 sine theta, so you can make that substitution and then you can distribute. Okay, and then if we want to know the slope of the line tangent, we're thinking about dy dx when theta is 0. And dy dx is going to come from y prime in terms of theta divided by x prime in terms of theta I didn't ever take its derivative. also didn't take this through. I'm sorry, hold on. I didn't actually do derivatives yet. Okay, x prime is actually negative 2.
How did you get notice being x? What happened to cosine x, or cosine theta times? Yeah.
Sorry, I meant to distribute here. And then I was thinking I did the derivative, but I didn't. So now the derivative is negative sine theta plus 2 times cosine theta is kind of a mess because I have to do product rule there. But if you only care about at 0 and you get to plug in 0 for theta everywhere, all that comes out to be 2. So since I'm saying this is 2. And then if you do y prime, so distribute, so that would be cosine theta plus, bring the power down, lower the power by 1, take the derivative of the inside, which again is kind of a mess, but because we only care about it at theta equals 0, plug in 0 here, here, and here, you end up with 1 plus 0, so which is 1. And y prime at 0 is the numerator part, so we can do the slope is 1/2. So a much more involved question, but notice I just said here's the formula for r, here's the formula for y. I plugged in what they told me r was. I distributed, I did a bad job of this, but I distributed to try to clean it up a little bit. I took the derivative. This one needed product rule, so it was a little more work. This one needed chain rule, so just be careful there. But it only really cared about where theta was 0 anyway, so once you had the derivative, a lot of this goes to 0. This goes to 0, this goes to 0, and this goes to 1. 2 times 1 is 2. Same thing with y. Plug in 0, you get 1 plus 4 times 0 times 1. So 1 plus 0, so you get 1. And y prime over x prime is how you find the slope of the tangent line, dy dx. So again, we'll talk about that again for a couple minutes. See, there's no school Friday, so Monday. So Monday we will spend a couple minutes talking about this stuff that we just did again, and then we'll move forward and look at question 5, and then practice through here. You can see this assignment does take a little bit more practice, which is why it's a little bit longer. But I'm not gonna make you start any of these today, but I really do feel like you could probably do, I don't know, questions 3, 4, 1's not too bad. A lot of them you could do already because they're just the converting, but I'll leave that up to you. If you do want to do a few, obviously that would be that much less you have to worry about on Monday. But for now, that is plenty. Okay, I will do my best to have the quizzes in gradebook today. Oh, I also promised I would get back your Unit 3 quiz. So I offered that to you last class if you finished your review in time. But I would let you see your third quiz. So, of course, this is numbered, so it needs to go back in your binder. It did. Your last thing? The whole thing? I'm not going to. You can just put a few in the back.
I'm not gonna get it. I didn't get I think I'll do that next time. Just like we were talking about.
be like best to just fill up the entire Tupperware. Like your own homemade donuts. Remind you to don't pull your stuff there so you don't.
Are we going straight after school? Oh, are you in that?
Yeah, wrestling.
Yeah, I'm in that too.
Oh, it's weird. It's the team.
It's Jurassic Park dinosaur costume, so the dinosaur
For our daily puzzle, I apologize if you haven't seen this one yet, but I think you did. No?
Nope.
You've not seen this one. Okay. I shared the answer and explanation to Google Classroom yesterday. So if you watched that already, then I guess you already know how to do it. But if you didn't, I guess this would be our puzzle for today.
Yeah, that's too much math.
Can you do anything like simple enough where we can just like look at them and like be mad if we can't get it or like?
So if I pulled out a ruler right
There's
now,
4 numbers on the screen.
If I pulled out the ruler right now and just measured that, would that be okay?
I don't think it's drawn.
That's a lot of numbers.
Yeah, so you should not assume it's drawn the scale. I will tell you the answer is a nice whole number. It's not some like crazy weird decimal. And I did have somebody in my AB class figure it out the other day, so.
So the difference between 20 and 25 kilometers per hour is miles per hour.
I feel like it would look easier if it was miles per hour. I don't know.
Well, there is a trick. You could just say it's miles per hour and then change it at the end, since.
Isn't that like 2,000?
Yo, that's so much math.
That's a lot of miles.
Solution, I'm not doing all that.
Wait,
You literally use graphs.
kilometers. Wait, but isn't that
In order to get the answer.
isn't that like 1,000 meters? This guy's running 2,000 miles an hour.
What if 2,000?
What?
2,000 meters.
But you also gotta
2,000
consider
meters.
him accelerating the as well.
Oh, yeah, that makes more sense. I was like, how fast is this guy running?
You could run 20 kilometers.
You don't know if the speed's constant either, so like.
25 kilometers per hour.
That's actually true. Going back to that.
Actually, I didn't think of it, but you know who that is?
I was thinking miles. I was like,
Brendan.
It is. That one day he came in and he was like pouring down sweat.
Oh, Kelvin,
But he was on
figuring
time
it
that
out.
day, weren't you?
No.
What's that?
You were on time that day, right?
Yeah, that was like the
Yeah.
one day.
Why'd you do that today?
Because it wasn't first thing shower.
Oh.
Are you going? Oh, what a loser this guy.
Maybe I will. Should I go?
Yeah, I mean, basically right after school, you just walk up to it.
Is it right after
Just
school?
like right after school.
It starts at 5.
So pretty much.
Oh, I'm gonna get hungry, dude.
And there's literally so many restaurants and
But
stuff.
that's
Believe
too much money, bro.
Always, your mom pays for your
No,
food.
he doesn't. She doesn't. You know how much money I've spent on food this month? Probably like $200.
That's crazy, boys.
I went to Canes like every day for like
Oh my God,
2 weeks
that's
this
horrible.
month. Yeah. Also paid for Catboy as well, a lot of those days.
Oh my God, that's just stupid. Kemp was getting free meals off.
I know. So, no, I'm just, I can, I'll play this.
There's so many places down here.
You can't know this.
Calvin, where do you live?
You got 10 minutes. Can you make it?
Yeah.
You live nearby then.
Oh yeah, I saw you. I
Yeah,
saw,
you remember in the summer? So Calvin was riding his bike and he just didn't look both ways
Too
when
big.
riding across the street. So
No, Brayden was driving like a maniac.
No,
Like he
so-
came around this corner like
I'm
90
driving,
to 20.
I'm driving down my neighborhood and going like 5 under the speed limit, which is the only reason I didn't hit you
This
because
guy's
I
not
wasn't speeding.
going this.
I was going like 5 under the speed limit, and Calvin comes flying from, he runs a stop sign, he comes flying on his bike right in front of me, and I just slammed on my brakes.
Is it the unicycle or just a regular?
A regular bike.
Oh, wait, it's minutes. Okay,
Yeah,
that's my.
Calvin just flying. I saw him flying in front of me.
Brayden was flying. I don't know what
If
you
I was,
did.
if I was going the speed limit or if I was speeding, I probably would have hit you.
Next time, let him hit you for insurance fraud.
I think it would still be Calvin's fault.
Well,
Oh.
no, it's
Oh.
always the driver's fault and a biker on the driver.
Man, I was gonna give you an A too. You didn't make it.
I'm trying again.
Free insurance money.
Well, now if you do it, you get an F.
Yeah, no.
Will.
So do you live by there, Calvin?
Does that hurt your neck?
No, you're not playing cookie.
Sort of.
No, actually it feels perfectly fine.
I might always do up.
It's just hard to keep it. If I go slightly more,
Yeah, me too.
it's gonna start sliding.
How come like cookie clicker was popular in 6th grade and now it's being popular with more seniors? Like every
You look very
place that we
pretentious.
Are you playing cookie
The way you turn to look at
Well,
people.
it's because
I'm trying to keep my head super steady. I almost feel like I'm in graduation day at one right now too.
Why weren't you in the house?
Are you guys doing anything fun with your extra day off?
Base it up.
I have a 0 for a 33.
Why not?
Oh.
I turned it in. I turned it in when we started class.
I get the 10 off.
Today?
I take
Yeah.
practice back to that after that.
That's weird.
Yeah. Watch this.
Okay, let me check the grade.
Oh,
Maybe it didn't save it.
No, that was as good as my
You know, Liam's the type of guy, you know, Liam used to play soccer as well, and then he quit during COVID, and then he came back, he tried out for the FHS team, and he didn't make it.
Even though I
He was all
there,
upset,
I
'cause,
was
yeah, he thinks he's the best at everything
Don't you have to be on a
does.
club team in order to be?
No.
Pretty much.
If you're on varsity though, I don't know about JV, because there was a lot of guys on JV who weren't on a club team. There was a lot of guys on JV who weren't on a club team, who were playing stat. You just wanted to
Name one person, bro.
Oh, is his name Christopher? No, Christopher, the Hispanic guy. Yeah, Christopher, Lucas.
His dad works at FHS, of course.
What was his name? The guy who was like skinny, friends with Sam and Wyatt.
Usually for like,
Yeah, Jackson.
if I ever have a
He wasn't on the club
problem,
That's all they do, so
There was a lot of guys who weren't on the club team. I was trying to figure out.
There was like 2 people.
Wyatt quit his job after a while as well, and then he rejoined for some
What he
reason.
knows though.
He doesn't work when it's
FHS software is directly connected, but it's not. Bro, the head coach literally owns.
Yeah, not Dylan.
The head coach is Coach
That one I assumed
Okay,
was.
it's
I would use it on the calculator part though, but I don't have the calculator at home.
Yeah.
Does know, but he was like simple is.
Yeah.
It would go, and then on my phone.
I must have gotten stuck. I didn't see it.
Okay.
Let me put it in.
Are most of the guys on the team like FC and comments?
Actually, I remember looking at this. I don't know what happened.
I was talking to Alan. Alan does success. He doesn't really like.
Number 4, you didn't pick up.
He says he talks about his glory days back in college.
His glory days, he played D1,
Yep. He says that all of the stuff he tries having you guys do is stuff that he did back when he played, back in the glory days.
Who is that?
Glory days. Coach Kaiser, do you know Owen Kaiser? Yeah, Owen's dad used to play D1 soccer, and apparently he's been like just going on and on about that with the soccer team this year. They've been trying to teach them stuff, but.
Does he work here? He's
No.
he's a volunteer assistant coach.
Oh.
He's very, very big into soccer.
Why does everyone have time for that? Like,
Owen is a pretty good soccer player, and so his dad is obsessed with soccer, so he
I'm pretty sure
his
maybe
volunteer soccer.
No, I was just laughing because there's like a Instagram video that a lot of teachers are laughing about where it's like the coach that works for the school, but he's a social studies teacher, and he didn't quite make pro until he shows World War II documentaries while he watches film tape on the side or something.
Yeah, that's Coach Davis.
And it sounded just like that.
That's Coach Davis. He teaches personal finance, but he's also one of the varsity football coaches. So like, I don't think he literally posts stuff, and that's about it. He doesn't really do
sports in high school?
Huh?
Did you play sports in high school?
I played baseball for a while.
What position?
Oh.
Okay.
I'm lucky either.
Can we put baseball in this classroom one day?
That would be relevant.
In this classroom?
Yes.
Physically?
Yes.
What if we like instead of real baseball and stuff, like let's use some.
You guys are damaged enough. You don't need.
We know, but hey.
That would be a good senior story. This like coming into Mr. Townsend's specifically
In this hallway. We should bowl in the hallway.
stealing all of the chairs and tables and stuff. That would be a good senior.
Why don't we bowl in the hallways?
Just leave me out of the senior prank, please.
All we have to do is like.
If y'all steal my chairs,
Yes. Well, I know like the football team comes from pre-K classes. I don't know the classrooms, but.
Oh, I owned a key for that.
Yeah, and then Liam returned it. Like an idiot. Exactly.
Never do that.
Because I
asked
asked.
Because he's a good That's crazy.
the best.
The stuff
Did I tell y'all the best senior prank that I've ever heard?
The alarms that were in the ceiling?
The alarm.
No, the alarms were horrible.
That was terrible.
They actually weren't.
What was it?
They were, well, there's only one piece.
Well, it was a long time ago.
They
It
shut
wasn't
off
here.
after it went off, like, right away.
But I guess somebody in student council was allowed to have like a school key. I don't know. It was a long time ago. And so they came up to school like in the middle of the night and then like called the news stations and said it was going to be a snow day. And it was like April or something, and they had a snow day. They just canceled school for everybody.
That's a great one.
One of the best senior pranks I've heard of is PT prank. So everybody bought a gallon of water, and they weren't going to do anything with it. But the teachers were worried that they were going to dump water everywhere, so they started taking water bottles from every student.